Important things to note. Regarding an exponential equation, y equals ab to the x power. First on the left, exponential growth. b is greater than 1. b is called the growth factor. The quantity y increases by a constant percentage each time period. R is the percent increase, written as a decimal. R is called the rate of increase, or growth rate. B equals 1 plus R. On the right, exponential decay. In this case, B is between 0 and 1. B is called the decay factor. The quantity y decreases by a constant percentage each time period. R is the percent decrease, written as a decimal. R is called the rate of decay, or decay rate. B equals 1 plus R, where the rate of decay R is expressed as a negative quantity. Take note, key concept: exponential growth and decay. You can model exponential growth or decay with this function. A of t equals a times the sum 1 plus r raised to the t power. In this case, a, the function, represents the amount after t time periods. A lowercase a is the initial amount. R, the rate of growth, or growth rate, if r is greater than 0. Or decay, the decay rate if r is less than 0. That sum raised to the t power, t is the number of time periods. For growth or decay to be exponential, a quantity changes by a fixed percentage each time period. Problem 3. Modeling exponential growth. You invest $1,000 in a savings account at the end of 6th grade. The account pays 5% annual interest. How much money will be in the account after 6 years? Step 1. Determine whether an exponential function is a reasonable model. Well, the money grows at a fixed rate of 5% per year, so an exponential model is appropriate. Step 2. Define the variables and determine the model. We can let t equal the number of years since money was invested, and the function a of t represent the amount in the account after each year. In this case, a reasonable model is a of t, capital A of t, equals lowercase a times the sum 1 plus r raised to the t power. Step 3. Use the model to solve the problem. In this case, we'll substitute 6 for t to represent 6 years, or 6 time periods that have elapsed. So a of 6, that will equal 1,000, 1,000 in place of a, the initial amount in the account, times the sum 1, 1 being built in and representing 100% of the initial amount, plus 0.05, representing r, or the rate, 5% interest, all raised to the 6th power. 6, again, in place of t, the amount of time periods, in this case years, that have elapsed. We'll work to simplify. This becomes 1,000 times 1.05 to the 6th power, or approximately $1,340.10. So we can state, in a complete sentence, the account contains $1,340.10 after 6 years. Your turn. Suppose you invest $500 in a savings account that pays 3.5% annual interest. How much will be in the account after 5 years?